So, good afternoon to all of you. So today's topic is strain gauge rosettes. Strain gauge rosettes. It is audible clearly. Audible and the screen is visible. Audible. Right. Okay. Right. Today we are going to discussing about the strain gauge rosettes. After completion of this class, you can gain knowledge on this strain gauge rosettes. So here, why before that, just I will give you a brief note of the previous class. In the previous class, we discussed about some various types of strain gauges. That is unbonded strain gauges, bonded strain gauges. In these bonded strain gauges, three types are there. That is metal foil strain gauges and wire, the thin wire, uh, that is bonded strain gauges, in the bonded strain gauges. And then next semiconductor or piezo resistive strain gauges. So these are the three in the bonded strain gauges. Two classifications are there. One is unbonded strain gauge, another one is bonded strain gauges. In the bonded strain gauges, again three are there. One is fine wire strain gauges, and the other one is metal foil, and the third one is a semiconductor. So these are the three gauges. In the unbonded strain gauges, it consists of two frames which are related to each other. And then with the help of the insulated pins, we have to stretch the wire along the four pins. And then whenever the force is applied on the frame, what happens means stress developed into that frames. Thereby, the strain is induced in it with the help of the whatever the wire structured along the insulated pins, which is connected to the stray Wheatstone bridge of one of the resistor. Then automatically you can get the deflection in the galvanometer, which is proportional to the strain which is induced or developed in the frame. And then similarly, same as it is that of the in the bonded strain gauges also. In the bonded strain gauges, we discussed metal foil and that is wire, fine wire. That is a fine wire strain gauge. Wire, or maybe the semiconductor, or maybe the metal foil. This whatever the strain gauge, we are bonding on a vibrating on a structure. That means a structure or beam whose strain has to be measured, or the structure under study. We have to fix that one with the help of some additive materials. And then these wire, maybe metal foil or maybe the semiconductor wire, these consists of leads. When these leads are connected to the one of the resistor of the Wheatstone bridge, then what happens means even the force is applied on a structure or a beam, thereby the stress developed, thereby the strain induced in it. So if the strain automatically, there will be a change in the resistance in the maybe metal foil or fine wire or in the semiconductor wire. So what happens means there will be change in the resistance takes place, which in turn deflects the galvanometer reading, which is proportional to the strain developed in the structure by applying force, right? So these are the, and also we discussed about the properties, strain, that is material properties. What are the materials used in strain gauges, and what are the properties, and also we also discussed about the additive materials. And also, so now we will discuss about the strain gauge rosettes. So why here, why we have to go for strain gauge rosettes? In the previous what we discussed, in the previous what we discussed, in the previous we discussed a strain gauge is placed on the structure whose strain has to be measured. So, but here, due to that, we can measure the strain only in one direction, where what that is what we discussed in the previous class. Here, for example, when the force is applied on a structure means the strain distribution should be different in different directions. For example, if you take the cantilever beam, this is the cantilever beam. That means when the force is applied at the end, when the force is applied at the end, that means here the strain developed should not be uniform, that should be in different directions. So here, with the help of the single strain gauge, so whatever you fixed or whatever you bonded in the structure, so it gives only a strain measurement of strain only in one direction. Whereas in the case of the strain, that means whatever the reading you got in that strain gauge, it should not be accurate. Of course, may be correct. To get the more accuracy, that means measurement of strain which is developed in the structure by applying force. So you have to go for strain gauge rosettes. Here the strain gauge rosettes here, same here it consists of this strain gauge. It consists rosettes means it consists of more than one strain gauge. In the previous what we discussed, only single strain gauges, it measures the strain in the structure developed only in one direction. But in the strain gauge rosettes, it consists of more than one strain gauge. It consists of more than one strain gauge, maybe one strain, two, more than one. That means two strain gauges or three or four to measure the strain in different directions, in different axes, so that whatever the strain developed in the structure, so it should be value is accurate. Value is accurate. So why we have to go for strain gauge rosettes means to get the accurate value of strain which is developed in the structure when the force is applied. Right. So that is why we have to go for strain gauges. So rosettes. So here in the strain gauge rosettes, it is a term. It is audible to all of you clearly. It is audible. So audible. It is audible. It is audible clearly. Right. Very good. So here the strain gauge rosettes. That means it consists of, you observe clearly, it consists of two or more strain gauges. That means more than one. More than one. If one strain gauge means it is not coming under strain gauge rosettes. More than one, that is two or more strain gauges, we have to position it in such a way that in different axes or in different directions to evaluate whatever the to evaluate or to measure a strain in different directions. Means we have to arrange the strain gauges, that is more two or more, in such a way that in that means we have to find out the strain in different directions to get accurate value. And single strain gauge can measure only strain effectively in only one direction. See here, here single strain gauge, when you place on a structure to measure strain of that structure means it gives a strain measurement only in one direction, but it is not the accurate value. It is not the true value. Of course, maybe, but it is it is not. We cannot get the correct value. Of course, maybe it is nearer to the true value. To get the accurate value, what we have to go for? We have to go for arranging of two or more strain gauges in different directions. We have to go for undervaluations for the measurement of strain. That means in different axes. You can say in different axes. So multiple strain gauges enables more measurements. Let me see here. You can get the strain measurement in different directions more if you go for more strain gauges. More to be taken, providing more precise value. That means precise means more precise of evaluation of a strain on the surface being measured. That means we can get the true value. Precise means it is almost all equivalent to the standard value. It's a almost all finest solution. That means optimized, we can get the optimized value in the measurement of strain. So in this, if you observe here, another one more figure, it is not visible here. D is there, but unexpectedly it is gone. Okay, right. Anyway, I will share. See here, this if you go for this is only one strain gauge. If you observe here, this is only one strain gauge, right? That means a uniaxial strain gauge with a single grid of measuring strain in only one direction. Only one direction. This is only one direction. And biaxial rosettes. Here, what is the meaning of the rosettes? Rosette means more than two or more strain gauges. We can call it as a rosette. What is a rosette here? Rosette means it consists of two or more strain gauges, or otherwise more than one strain gauge. So here biaxial means two axes. Here we are arranging, biaxial means here we are arranging two strain gauges in two directions. So that's why you can call it as a biaxial. Uniaxial means only one axis, only in one direction. Only in one direction. Whereas biaxial means two axes. Here the strain gauges we have to fix in such a way that in two axes or maybe in two different directions. So biaxial means two perpendicular grids used to determine principal strains. Here, whenever you can go for axis, two different axes, then so here you have to determine the principal strain in a, for example, x-axis and y-axis. That means which are both are perpendicular to each other. So I'm drawing here two axes in a structure. For example, this is a structure. So vibrating structure, this is a structure. Here, this is a y-axis and this is x-axis. Here we have to arrange in this direction one strain gauge and here one strain gauge. So here in this vibrating structure, so here this strain gauge gives the strain in x direction. So there here the principal stresses and principal strain are there, and in y direction principal stresses and the principal strains are, that means sigma x and sigma y. That means stress developed in x direction, the stress developed in y direction. In the previous case, what we discussed, when the gauge is placed on a structure, the stress developed in the body. So that is only one direction. But here we are placing two strain gauges, means we have to go for stress developed, principal stress developed in x-axis and maybe in y-axis. We are naming it as two different directions, means x and y. And strain, that means tangential, right? Tangential or normal, right? Yeah, absolute right. Tangential or normal. And sigma x is nothing but principal strain developed in x-axis, and sigma y is the principal strain developed in y-axis. So we can calculate it separately. That means a strain developed in one direction, strain developed in another direction. So like that. So here the principal strains, we have to calculate the principal strain to determine with their directions known directions. So see here, that is a biaxial. This is a biaxial. And three element rosettes. That means three element rosettes means here three strain gauges are arranged in three different directions. See, three independent grids means here directions in three directions, the axis, for ascertaining the principal strains and their direction. Similarly here also, sigma x, sigma y, and sigma z. We have to name it as sigma x, sigma y, and sigma z. And this strain, say this epsilon x, epsilon y, and epsilon z. We can go for strain measurements in three different directions. And for that, having what you learned in the previous semester, MOS, already MOS, now you are having MOS, or already you studied MOS, mechanics of solids or engineering mechanics. You studied the MOS already, you studied in previous semester, right or wrong? Now going, okay, right. And mechanics, you know very well, you know very well, you studied about the principal stresses and principal strain, Morse circle diagram. You learned or not? Principal stresses and principal strain in mechanics. Today class, BNV sir is going to discussing about principal stresses. Mr. Raviteja, now studying. Okay, right. Okay, right. So there, sir will explain clearly, step by step. But here I am writing direct. I am giving the expression, direct expression, to determine the principal stress as well as the principal strain in different directions or different axes. And this is a shear. Okay, right. So here it is visible to all of you. It is visible clearly. Completed it is. Okay, okay, okay. Okay. Visible. Okay, right. See here, if you observe here, this is the strain gauge 1. See here, this is strain gauge 1. It is in this direction. Observe clearly, which is structured and bend again and again. And these are the two leads. And another strain gauges here we are arranged in this direction. So both are perpendicular. Here, this is a vibrating structure. This is a vibrating structure. That means these two strain gauges are arranged in different axes, which is perpendicular to each other. Perpendicular to each other. So that one we can call it as a two-element rosette. That means rosette means here two strain gauges are there, which are arranged perpendicularly on the structure whose strain has to be measured. That is biaxial. Am I absolutely? That is biaxial. Correct. Biaxial or two-element rosettes. That means both are same. And if you go for rectangular rosettes, that means three elements rectangular rosettes. Here, three elements. We can call it as a three element. That means three strain gauges, rectangular rosettes. Here, see, if you observe clearly, here three strain gauges are arranged. These three strain gauges are arranged on the vibrating structure, and then it is bonded with the help of the adhesive materials. And these three strain gauges are arranged perpendicular to each other. See here, if you observe clearly at here, this is in the x-axis and this is in y-axis and this is in z-axis. That means three strain gauges are arranged in such a way that three strain gauges are perpendicular to each other, so that you can get the measurement of strain, you can get the accurate value, and it is a precise value, which is equal to the average, that means which is equal to the true value. And if you go for a three element delta rosette, that means here also three strain gauges are there. Here we arranged what one person said, that tangentially, one person said that about tangentially and normal stresses. Here in this, it is arranged in this way, delta, that is a triangle. That is three different directions. If you observe clearly in this first strain gauge and the second strain gauge and the third gauge, these three strain gauges will measure the strain in three different directions. So right. So now you observe same. This is the same procedure. Whatever the leads, you have to attach to the resistor of the Wheatstone. Here, this one you have to attach. See here, we have to connect to the one of the resistor of the Wheatstone wheel, that is R1. Here we have to connect to the another R2 resistor of the Wheatstone bridge. Here, for example, if three, we can connect R1, R2, R3, three resistors of the Wheatstone bridge, and then thereby there will be change in the resistance takes place in the strain gauge wire. So thereby what happens? So the galvanometer deflects, so we can get the reading value, this which is proportional to the strain developed in the measurement. Otherwise, you can go for calculation, how to determine the value of the principal stress in x direction, principal stress in y direction, or strain in x direction, strain in y direction. And also shear strain is also there, so that we can get the accurate value. Those are here I written clearly direct expressions, but in the MOS you can get the clear idea about that. So these, if you see the strain gauges, see here 2-element rosettes. If you go for 2-element rosettes, these are the principal stresses. Sigma 1, that means one in one direction, and sigma 2 is another direction. That means principal stress, Young's modulus of elasticity. So this is a formula. Are you seeing this formula? You seen this formula? Seen? No. Okay, right. So there, maybe in mechanics also it is there, and maybe the BNV sir will discuss this one. With the help of this formula, we can determine the principal stress in two directions, and also shear stress is also we can go for calculate. So these epsilon 1 and epsilon 2 are the strain. So with the help of this formula, we can calculate the strain development. Okay, Masunil. Okay. There you can get the expression, but not required. So with the help of this one, we can go for calculation. So what I expressed clearly at here, here we can determine, see here, can go for determine principal strains, right? So through calculations. Otherwise, we can go for directly, can connect the resistors in the Wheatstone bridge, we can get the direct value. This is a theoretically we can go for calculation. And then for three element rectangular rosettes, that means 3 strain gauges, epsilon 1, epsilon 2, epsilon 3 are the 3 strain gauges, strains developed in the 3 strain gauges. These are the principal strain, and that is a maximum and minimum. You can go for directly maximum principal stress, and this is a minimum principal stress, maximum principal stress. Similarly, minimum strain developed and maximum strain developed. So they have the help of these formulas, and also the location of, that means angle also. Angle also, tan 2 theta we have to measure with the help of this one angle measurement. And for 3-element delta rosette, that means 3 strain gauges which are arranged in a triangle. So for this maximum strain and minimum strain, the minimum strain, the formula, and for principal stresses to determine the principal stresses. So minimum stress and maximum strain, this is the formula, and the shear stress, and for this is the formula. And then now we will discuss about, see here, if you observe clearly strain gauge rosettes, here this is only one strain gauge, here it is only one strain gauge. Here it is only one strain gauge. We are connecting to the resistor of a Wheatstone bridge. Here in another one, a rheostat is there. Rheostat is nothing but variable change in the resistance. Otherwise, regulating, we can regulate the resistance. We can regulate the resistance. What's the time now? So, okay. We can regulate the resistance. Here, whenever the strain gauge, one of the strain gauge is connected. So first the bridge is balanced. All of you know that R1 by R2 is equal to R3 by R4. From this, we need the value of the strain developed or the resistance developed in the strain gauge. This strain gauge here we are fixing on the structure whose strain has to be measured, right? So here that R1 value is that resistance developed in the strain gauge, that is R1 is equal to R2 into R3 by R4. Okay, right? Here this one. Here, what we are doing, whenever a strain gauge is connected to the resistor of a Wheatstone bridge, here this strain gauge is placed on the structure. When the force is applied on the structure, strain developed. Whenever the strain developed, automatically there will be change in the resistance takes place in the gauge, strain gauge. So what happens means this gauge will in turn deflects, this galvanometer in turn will deflects. So here, uh, so what we have to do deflects. So with the help of this rheostat, we have to adjust the resistance, or otherwise we have to change the resistance in such a way that this galvanometer shows zero ring, that means in null deflection. Here with the help of the rheostat, you are adjusting the resistance. How much you changed the resistance? That resistance is nothing but which is developed in this strain gauge. I understand? You got the point. Here the strain gauge, here this strain gauge is placed on the structure, right? So whose strain has to be measured. When the force is applied on the structure, what happens means there will be a strain developed or strain developed in the body. So this strain is absorbed by a strain gauge. Thereby, strain gauge is nothing but a resistance wire. So this resistance is why there will be a change in the resistance. Once there will be change in the resistance, the galvanometer deflects from zero reading. If it is galvanometer shows zero reading, means it is null, that is in balanced mode. So when the galvanometer deflects, there will be a change in the resistance, right? How can you find out how much resistance is induced in this strain gauge once the galvanometer deflects? So for that, what we are doing, with the help of the rheostat, you are adjusting such that the galvanometer again it returns to the zero reading. And so how much you changed with the help of this variable resistor, that change of resistance is nothing but the strain in the resistance in the strain gauge, the resistance in the developed in the strain gauge. So now you got the clear idea. Force applied, strain developed, change in resistance in Wheatstone bridge, measuring caliber correlated with the change in strain with the help of the rheostat. Here you return, one person return force applied, correct, the strain developed, right, change in the resistance in the Wheatstone bridge, correct. So that measurement in the galvanometer. Okay, right. After measure galvanometer getting reading, that is voltage. So with the help of the rheostat, what we are doing, rheostat is nothing but a variable resistor. We have to adjust the variable resistor in such a way that again the galvanometer shows zero reading, that is balanced. So how much you adjusted the resistance, right, with the help of the rheostat. So that adjustment resistance is directly you can get, that resistance is nothing but which is developed in the strain gauges. How to understand now? Okay. So now see here in which way. See here for example here R1, R1 is nothing but this is R1. This is R1. R1, this is nothing but strain gauge resistance. Whenever it is placed on the structure, automatically change in the resistance takes place. That change in the resistance is nothing but this one plus dr1. And similarly, you are changing the variable resistor by a change of dr2, which is equal to r3 by r. Here this one you are substituting it here in this equation. R1 plus dr1 change in the resistance, R2 plus dr2. That means here we are changing here this one and this one. There will be a change in the resistance in the R1, and there will be a change in the resistance in the rheostat dr2. So from this R1 plus dr1, we have to go for simplification, and then we are getting dr1. That means we have to find out how much strain developed in the structure. So this strain gauge we are connected to the resistor R1. So dr1 is nothing but dr2 into r3 by r4. So actually this is the formula, right? So with the help of this formula, we can also find out that how much change in the resistance takes place in the strain gauge. Change in the resistance, D is nothing but change, right? With the help of this formula, we can also find out. But one thing, again one thing. Of course, maybe with the help of this strain gauges, whatever you connected to the Wheatstone bridge, but we cannot get the accurate reading. So because in the rheostat, in the variable resistors, the temperature develops. This temperature develops means it will not give the correct reading. Again, due to the temperature, what happens means whenever with the help of the rheostat, if you change, due to the temperature, some of the resistance may change more. That means negligibly more, but we cannot get the accurate value. For this temperature compensations, what we have to do? What we have to do? So we have to remove the rheostat or the variable resistor, and then we have to place a dummy strain gauge to eliminate the error. Right. See here, strain gauge rotates. Here, for example, strain gauge, go temperature compensation. Temperature compensation. Here, see, in the previous, it is a strain gauge. Of course, this is a strain gauge, R1. This is active strain gauges, which is placed here, structure under study. Structure under study. And then here we are going for a dummy gauge, dummy strain gauge. So by arranging a dummy gauge, we can increase the sensitivity of the strain reading. So now you got the point, right? Or you understand? So by arranging a dummy strain gauge in place of the rheostat, we can increase the sensitivity of the strain. We can increase the sensitivity of the parameter strain. But so by using the Wheatstone bridge, we can go for a temperature compensation. Remember this point here, some difference is there. Here by using a dummy gauge in the place of the rheostat, what we have to, we can go for increasing the sensitivity of the measuring of the parameter strain value, right? Whereas this dummy gauge and activity gauge, we are incorporating in the Wheatstone bridge, this entire circuit gives for the compensation of temperature compensation. Somebody said that the resistance alters. Mr. Ravitejan? Resistance also. The 10 minutes time is there. So almost all members are very hungry. Okay, I will leave within 5 or 10 minutes. 5 minutes. So I request my dear students, please bear for 10 minutes. So nearly the time is 1 o'clock. You are in Hungary, right? You please bear for 5 minutes. I will close the class. Okay. And the next, see here, so with the help of this, again I'm repeating, the dummy gauge, by arranging a dummy gauge, we can increase the sensitivity of the variable strain, right? So with the help of this arrangement of this Wheatstone bridge, by arranging one resistor of the dummy gauge and in one resistor active gauge, that is which is connected to the structure. So with the help of this, we can go for this arrangement, that is dummy gauge, active gauge, this Wheatstone bridge, circuits, total entire. This will go for compensating the temperature compensation, right? So same. So with the help of this, we can go for same as it is here. When it is placed in the structure, automatically what happens means there will be a change in the resistance of a gauge, which in turn deflects in this one, right? The galvanometer. Here arranged it. Maybe here strain gauge rosets I am writing here. Here we can go for another, we can go for attaching for another strain gauge, another one more active strain gauge, active strain gauge. And that this is first active strain gauge, and we can go for this is another, this is one active strain gauge one, and AS2 like that. I am giving nomenclature. And here we can go for another strain gauge. So three strain gauges like that. Thereby the galvanometer deflects, which in turn proportional to the strain developed in the total entire structure. So, so next we will go for the next one. And this is also in the cantilever with the help of the two strain gauges. For example, here the cantilever beam is there. We have to measure uh, the strain. So here we are arranging a compensating gauge here, and here another active gauge to measure. That means we have to place a top one strain gauge and another compensating gauge strain gauge we have to place under the beam. So here when the force is applied at here, so if you observe clearly, here it is connected to the one resistor, and here it is connected to the another resistor. Same procedure here, that here the galvanometer is there, right, galvanometer, right. Here sometimes we can also arrange, that means this gauge, when the force is applied, then it undergoes in this direction, right, this undergoes, the cantilever beam deflects, right. Here that means in this strain gauge, that means a tensile stress develop. Whereas in the case of the this compensating gauge, here it absorbs the compression strain. Here the compression, here at this spot the compression takes place. And sometimes we can also arrange in such a way that I will write with you. See here, all of you see clearly, this is a strain gauge. See here, here we can arrange one strain gauge, here one arrange, we can arrange one other strain gauge. To get a more accurate value, you can go for 4 strain gauges. So this strain gauge we can connect at here, and this strain gauge we can connect at here, and this strain gauge we can connect at here, and this strain gauge we can connect at here. We can connect these 4 strain gauges, we can connect it to the 4 resistors of a Wheatstone beach. Then we can go for finding out the correct value of strain which is developed in that beam. Like that, okay, right? So this one we can call it as a, all of you see here, here the 2 strain gauges are arranged beam. This one we can call it as a half bridge. That means half bridge, that means 2 resistors are connected to the strain gauges. Or understand? So that we can also call it as a half bridge 2 active strain gauges in the cantilever beam. So for example, it is not there, only one strain gauge is attached, then we can call it as a quarter bridge. That means one strain gauge on a cantilever beam. For example, 4 strain gauges, what I discussed with you, 4 strain gauges are arranged, top 2 and bottom 2. These are the 2 find outs the tensile, and these 2 are compressive. See here tensile, so here we are calling it as a tensile, means whenever the force is applied, it undergoes deflection like this, then automatically at here tensile develop, at here compression develops. So here we are arranging 2 strain gauges to measure compressive strain, and here a tensile. So when you connect these 4 strain gauges in 4 resistor, then we can call it as a full bridge. That means full bridge is occupied by the 4 strain gauges. So now, okay, right, time is over. So I will end the class now. Here I have not uploaded the quiz questions, but here due to some network problem, so whenever I upload the quiz in the LMS, I will intimate to you through WhatsApp group, so you can be alert and then you can write the exam. Correct. Thank you to all of you. So I will take the attendance from the previous. So those who are not came to the previous class, just you drop a message to me so that I will give attendance. Thank you to all of you. Thank you to all of you. Okay, 40. 1 minute 40. You are not came to the previous class. Am I right? Right. Okay, right lateral entry 40. Anybody? Just drop a message. And 14, 19th batch 14. Okay. Next 11. Okay. Next 54 lateral entry. Okay. Next 32 lateral entry. Not okay. 339. Okay. Next 50 20. 18th batch 320. Okay. And 30 59. Okay. 59. And the next 1 minute. 1 minute. Slow. I'm up to 59 one. 59 7. So these are all who are not, you are not came, right? You are not came to the previous class. 9:30, right? 26 lateral entry. 10 lateral entry, right? 20 lateral, 20 regular, right? And 59 regular, right? Already written. Okay, right. Thank you to all of you. 29, 20, and then next 29. I written 29 regular, kadamma. 29 regular. And 52 regular, right? And 308 regular, right? Okay. And 331 regular, 331 regular I already given, and 302 regular, right? 320 regular. Okay. 3 yeah, under postation. I'm asking that to those who are not came to the previous. Okay, right. Thank you to all of you. So I will see it. Already all are posted, right? So I will go. I will check. I will check. No issues. No issues. If you are already all are posted means, then I will check. Huh? Okay, I will take the. I will go. I will go through that, and then I will take. Okay, thank you to all of you. Then now the time is okay, right? I'm going to go for lunch. Thank you. Thank you to all of you.